Hello everyone, welcome to this virtual discussion on Astable multivibrator circuit using transistors. First of all, to design and to study the Astable multivibrator circuit using transistors, we should know the aim of this practical, and basic aim of this practical is to build an Astable multivibrator circuit and display the output waveforms on CRO and to study these waveforms so that we can study Astable multivibrator circuit in detail. For this particular experiment and this practical, we need some apparatus, and apparatus required are DC regulated power supply and cathode ray oscilloscope, which we call it as a CRO. These are the some of the components without which we cannot build our circuit, Astable multivibrator circuit, right? So we need 0.01 microfarad capacitor, 100 kilo ohm and 6.8 kilo ohm resistors, and BC01 transistors. We will require two transistors. First of all, what is a multivibrator? Listening to this word, you might think that what is multivibrator and what we call it as a why we call it as a multivibrator. So multivibrator is nothing but it is an electronic circuit which is used to implement a variety of simple two-state devices such as oscillators, timers and flip-flops. And this particular circuit, it consists of two amplifying devices cross coupled to each other by resistors and capacitors. And in this particular practical, if we see, then those amplifying devices are nothing but transistors, right? A multivibrator circuit oscillates between a high state and a low state, producing a continuous output that you will be seeing in your waveforms. These are the types of multivibrators. Going ahead, we should be knowing about the types of multivibrators. Here is a small assignment for you all to study and to know more about the monostable multivibrator and bistable multivibrators circuits, right? And if we look into the astable multivibrator circuit, then specifically there are no stable states in astable multivibrator circuit. And also, if you see the output waveforms of this circuit, of this astable multivibrator circuit, then the output of this particular circuit, it continuously changes from one state to the another state, right? Moving ahead, this is a circuit diagram. We have applied plus VCC to the transistors through resistors and capacitors, through base resistors, collector resistors and capacitors. Now, the output of this circuit can be changed by the passive components with the help of the passive components such as resistors and capacitors. And as I told you, this circuit includes base resistors and collector resistors. Now, here one thing you have to remember, that is here there are two transistors Q1 and Q2. Here Q1 is named as TR1 and Q2 is named as TR2. So this both the transistors basically in this particular circuit, this both the transistor in this circuit are cross coupled to each other, which means that collector of one transistor is connected with the base of the another transistor using capacitor. So that is very important to remember. And first of all, going ahead to understand, to learn the working of this particular circuit, we should be knowing about this thing, transistors as a switch. Here we are using transistor, but we should be knowing how it works. So transistors in this particular circuit, transistor works as a switch. What is that? Now whenever input to this bipolar junction transistor are less than 0.7 volt, then it will operate in cutoff region, which means that it acts as an open circuit. right? So it means that whenever we see the voltage VCE, that will be approximately equal to VCC. And another thing, if we see the input to this bipolar junction transistor is higher than 0.7 volt, then it will operate in saturation region. That means that it acts as a closed circuit, which you can see in figure 1 cutoff, that is open switch, and in figure B you can see that it works operate in saturation region, which we called it as a closed switch. Going ahead, to understand the working of Astable multivibrator circuit, first of all, initially let us consider that there is no power supply given to this particular circuit, right? So at that time, both the transistors will be in the off state. It is very much understood that when you don't give any power supply, no VCC, then you can imagine that both the transistors Q1 and Q2 will be in the off state. Now, as soon as we try to apply the voltage supply, then what will happen? As soon as we apply the voltage, then both the transistors will try to conduct, right? And when the voltage is applied, at that time the capacitors will start charging. We know that it simultaneously starts charging, but how they start charging, that we need to understand. So here you will see that basically in our circuit we have designed in such a way that sorry, in such a way that the value of collector resistors is less than the base resistor, right? And therefore in the circuit the transistors will charge through the collector resistors and not through the base resistors. This thing is very much necessary to understand, that in this particular circuit our transistors are connected and our capacitors are charging through collector resistors and not through the base resistors. But in this one, both the transistor will not conduct same way. One transistor may conduct more than the another one, and that happens due to the mismatch in the circuit. Sometimes there is a mismatch in the circuit and that does not work simultaneously. So due to that thing, one transistor will go to saturation first, that may be any of them first, right? So it is not fixed that which transistors goes into the saturation first. So let us consider that transistor TR1 or transistor Q1 goes to the saturation first. Now as I told you earlier that if goes to saturation, its collector emitter terminal will act as a short circuit, right? When transistor Q1 goes to the saturation, then its collector emitter terminal will act as a short circuit. Now due to that, the capacitor C1 might have accumulated some charge on it, right? So as transistor Q1 is short, the left hand side of capacitor will be grounded, and therefore the negative voltage will appear at transistor Q2, and Q2 will be in the cutoff region. So what will happen? This way any one transistor will remain on and another transistor will remain in off condition, right? So at this stage we will see that Q1 is in on state and Q2 is in off state. Now usually we are measuring the outputs from collector Q. Here we can see that Q and another output from Q bar, right? Now as we see that both the potentials are negative or opposite to each other, and therefore we get opposite waveforms at particular time. If we see the outputs at Q and Q bar simultaneously, then you will see that there is a totally inversal of waveform at a same particular time. So when we see that C1 capacitor charged in another direction through RB2 and C2 charges through RC2. So as Q1 is on, we saw that Q1 is in on condition. So as Q1 is on, therefore it is forward bias. We can say that base emitter junction is in forward bias and voltage across it will be 0.7 volt. Therefore we can say that left hand side of capacitor 2 C2, we can say that left hand side of capacitor C2 will be also accumulating 0.7 volt, and therefore C2 charge is up to VCC minus VBE of Q1, right? And VBE will be same for both the transistors. We should keep that thing in the mind. Now also capacitor C1, here we can see that in our circuit capacitor C1 starts charging through VCC, right? And also RC2 is less than RB2. Here we saw that the value of collector resistors are less than value of base resistors, and therefore C2 charge is faster as compared to C1. Now whenever capacitor C1 charges up to 0.7 volt, then that 0.7 volt will also appear at the base of the another transistor, that is transistor Q2. Therefore we can say that our transistor Q2 here in our circuit, it is TR2, starts conducting and goes to saturation region. Therefore Q2 will act as a short circuit. Until then C2 was charging, capacitor C2 was charging, and it will be charged up to VCC minus VBE. As I told earlier, that it will be charging up to VCC minus VBE, and after that when Q2 will act as a short circuit, then capacitor C2 will be grounded, and voltage appearing at the base of Q2, that will be negative of VCC minus VBE, and due to this negative voltage, as we saw previously, due to this negative voltage Q1 will be off, in the off state. Now transistor Q2 is in on state and Q1 is in off state. The state is totally inverse. Here we come to the second state of astable multivibrator. Now in this particular second state, if we check the voltage at point O and O bar, output O and output O bar, here in our circuit we can say that output Q and output Q bar, and we check the output at Q, then we will have the higher values, that will be nearly around plus VCC, and when we check the output at Q bar, that will be around 0 voltage. That means it has a low value, right? So in this case capacitor C2 charges in reverse direction, that is VCC minus RB1, and Q2 is ground. Also capacitor C1 charged through resistance RC1, and therefore we can say that VCC minus RC1, and again Q2 is ground, right? So again we can say that when in this circuit, when C2 charges up to 0.7 volt, then Q1 is in saturation region, and C1, right, Q1 is in saturation region, and capacitor C1 charges up to VCC minus VBE, and that means that capacitor C1 is again grounded, therefore we take it as a negative. So negative of VCC minus VBE appears on transistor Q2, and therefore transistor Q2 will be in off condition, and again transistor Q1 will be in the on condition. So once again we can say that we have came to the same state as the previous one, and in this particular circuit on time and off time is decided by the charging and discharging of the capacitor, that you can understand. Now after seeing to the working of the circuit, let us see the practical demonstration how we do that. So now we will see the practical demonstration of this particular experiment. We will connect our circuit which we have prepared on the PCB, general purpose PCB, and we will take the waveform, output waveforms in the CRO. So this is our DC 0 to 30 volt power supply which we have given to our circuit. Here you can see that all the components are soldered on our general purpose PCB. Here you can see that transistor Q1 on left hand side and transistor Q2 on right hand side, followed by two 0.01 microfarad capacitors which are connected in the collector of the transistors, then followed by two collector resistors, and in the green color you can see the base resistors. We have given power supply plus VCC to our circuit and also ground. Now we want to see the output of first transistor, that is Q, output 1 from transistor Q1. Here we insert the probe and we want to check the output in the CRO. Here, yes, we can see the output of output 1, which is we say as output Q. And now we will check and insert the probe of channel 2 in the output of another transistor, and that will be our output Q bar, which we called it as a second output. And now we will see both the output waveforms in channel 1 and channel 2 in our CRO. Yes, here you can see in the blue you will see the output Q, which is our output 1, and in yellow you can see the channel 2, that is output Q bar of our circuit. And with this help of this measure button you can measure the various parameters with the one click. And with the help of this scale button, first of all you have to select the channel, and then you can change the amplitude of that particular channel. Then clicking channel 2 you can also change the amplitude of that channel. Further, with the help of this scale button you can vary the time period of that particular waveforms, and you can decrease or increase the time period according to your convenience. As I told you, with the help of this measure button, here you can see the various parameters of this particular waveforms, including time period and everything we can get on a single click. So this was all about Astable multivibrator circuit.